Hello everyone. In this video, I will be discussing on the data transfer instruction of 8085 megahertz. First, we'll have an introduction to what are the different types of instructions are there and how this has been classified in your 8085 microprocessor. Then we'll be discussing on the first category of instructions, that is data transfer of 8085 microprocessor. So coming to the objective of this lecture helps the students to gain knowledge in 8085 microprocessor data transfer instruction. First, instruction set of 8085. What is said to be an instruction set? The entire group of instructions that a microprocessor supports is called an instruction set. So in your 8085 microprocessor, we are having a total of 246 instructions. 246 instructions, and each instruction is represented by an 8-bit binary value, which is called as an opcode, which is called as what? Opcode or instruction byte. So this classification of instruction is been categorized into 5 categories, one after the other. We'll discuss those categories. The first one category of instructions is data transfer instruction. Next one is arithmetic instruction. Third one is logical instruction, branching instructions, and control instructions. First one is data transfer instruction. Which type of instructions are said to be a data transfer instructions? Why these are called as data transfer instructions, and how these will be helping in designing the program. These are the most the foundations or the builders of the programming which are used. So data transfer instruction, what it does is that these instructions helps to move a data between register to register or register to the memory location, and from the immediate to the memory location onto the register, so on and so forth. And one thing you need to remember is that data from source and destination, we are moving it up. It should not be both should not be a memory location, and both should be of same type, 8 bits or 16 bits. Coming to the first category of data transfer, which is MOV. So here, the source and destination should not be a memory location. The source is a register. It can be a register or it can be a memory location. If your destination is a memory location, it can be only source is a memory location. Destination can be only a register. Both these are some of the examples. Move B comma C. So the B content is being copied with the contents of C, and whatever the memory value stored at the memory location point by H and L is being copied into the B register, which is move B comma M. The M represents memory location. It will go to the memory location pointed by H and L register pair, and it will copy into the B register. This is about the move instruction. Similarly, onto the move instruction, one more type of instruction which is given MIVI, move immediate. Here, the immediate value is being moved into the specified memory location or the register. These are the two instructions related to the move, and here we are having two instructions which are related to the LDA. First one is LDA, load accumulator. So here what it does is that it loads the accumulator. Accumulator is what? A register. It loads A register with the content equals to 2034. 2034 value is being loaded into the accumulator A. It will go to the location 2034. Whatever the content is there in that location, it will copy it and then loads into the accumulator. Similarly, LDAX. Previously, it was directly the address would be given. Now here, B and C register will be holding the value of where the value is being stored. It will go there, it will take the value, and it will be loaded into the accumulator. LDAX. LDA, the direct memory address will be given. X indicates the pair of register will be holding that. Next one, LXI. This is about loading an register pair with an value, immediate value, like LXI comma 2034. Now this 2034 is an immediate value which is copied into the HL register pair, 16-bit HL register pair. LXI B comma 2034 means B and C register would be holding the value which would be loaded with the value as 2034. Out of the 2034, 34 is the lower byte, 20 is the higher byte. Likewise, load HL direct. It would be the direct memory location which would be pointed over here. So this location, it will take a byte and it will be loading into the first is L register, then in the next memory location 2041, it will be loading into the H register. Load HL register pair with the direct memory address which is shown. And next one, these are the instructions related to the, like load is there, here it would be stored. In the load, it is taking from the memory location into the accumulator. Here, from the accumulator, it will go to the memory location 2500, and whatever the value stored in A is copied into the. And for all the load, store, move instructions, neither the source nor the destination contents are changed or modified, except one of the instruction called as change. We'll discuss that one. STAX. STAX, what it does is that it will check the BNC register pair, whatever the value in the BNC register pair, it has been copied into the A register. This is about STAX. Similarly, SHLD, it will go to the memory location 2550. Then whatever the value is there, it was copied into the L register, and the next memory location value is copied into the H register. It's similar like LHLD, but previously it was an load was there. This is store. So here the L value is stored at what 2550 location. H value is stored at what 2551 location. Storing the values. Previously SRH would copy the value. Now I told you one of the instruction which only the instruction where source and destination are modified is nothing but exchange. So what happens over here is in the exchange is that exchange would be implicit instruction where the source and destination are fixed for every time. So then what it does is that the H content is been moved to the D content, and D content is exchanged with the H content. So H and D will swap the values. Similarly, L and E register will swap the values. When you see the exchange content automatically display. And next, very rarely we'll be using regarding the stack pointers. What it will do is that copy the HL register pair to the top of the stack pointer. To the top of the stack pointer, the value would be copied. And the exchange would be taken up with the top of the stack with the HL register pair using of XTHL. XTHL would be. Next one is that whatever the counter value is there, program counter value, if you want to load it up, you can load that counter value by giving it as PCHL. PCHL is one of the instruction where the program counter 16-bit value is copied into the HL register pair. This would be used when you want to know the opcodes or the way the values are stored, something like that. The next one is about push and pop. These two instructions are used for moving a value into the stack and copying a value from the stack. Push will move the contents to the top of the stack, and pop will copy the content or remove the content from the top of the stack and to the specified register which is shown. Next one is two instructions relating to the input and output peripherals. Out, it will send you the address of the 8-bit address port. It will be sending it up through which the data is being sent or received. So this is one of the example of out. Similarly, you are having one more is what in. So in the instruction, what it does is that it will copy the from the output port. It will take a data and it will be copying into the specified accumulator. From the accumulator, it will go out and it will be copying into the external environment, and for the in instruction, it will be copying it from the IO port into the accumulator. These are all the instructions relating to data transfer category of instructions. So in the data transfer category of instructions, you are having move instructions, load instructions, and in and out, with last one is exchange instruction. So thank you for watching this video. I hope you have been able to develop how to develop a program using of this data transfer instruction.